Hello viewers, welcome back once again in the mathematics next session of JanataTelevision. In the collaboration of JanataTelevision, Pabson has organized a distance learning program. So today also as like in the bygone day, we are going to discuss about the same chapter, mensuration. And dear viewers, we are discussing in the bygone day about deriving the different types of formulas of the regular figures like plane surface area as well as the solid shape. So today, at the time, I had talked about the use of this formula 1 by 2, and in case of a triangle, okay, in case of a triangle ABC, for example, is a triangle, okay, and if what middle angle is given, then by taking the product of two sides AB into BC into the middle angle, that means in between the two adjacent sides, the angle in terms of sine, angle B. So by using this formula, how many formulas can be derived, we discussed in the bygone day. So today we are going to discuss, dear viewers, regarding the use of this formula, okay. By the help of this formula, how many formulas can be derived? For example, this is a general triangle, and this is the perpendicular or the height drawn from the vertex of the triangle to the base, and this one is base. So if such type of figure we can make in any type of plane surface area, at the time we can use to find out the area of this figure as 1 by 2 base into height. 1 by 2 base into height. So by the help of using this formula, basic formula, how many formulas can be derived? Let's see. Today I am going to derive some of the formulas by using that formula. Okay, first of all, I want to take the isosceles triangle, okay. In case of isosceles triangle, how to derive the formula of isosceles triangle? By the help of this formula, we can derive, dear everyone, viewers, the formula of isosceles triangle. So what like triangle is known as isosceles triangle? First of all, let's prepare a triangle which is having the properties of isosceles. The two sides are equal and the two base angles are equal. These two angles are equal, but in this case, in order to derive the formula, is we don't need the angles, so I'm just taking the sides of the triangle. Let's suppose the equal side as x, dear student, and then after non-equal side as a. The length of non-equal side is given as a, and then after the two equal being sides measurement is mentioned as x. Now let's draw a perpendicular line from the vertex of the isosceles triangle, okay. At the time what happens, there forms a theorem, okay. There is a theorem, or line through the vertex of a perpendicular line through the vertex of an isosceles triangle is perpendicular bisector to the base. It means when a perpendicular line comes from the vertex of the isosceles triangle, at the time it divides the base into two equal halves. That means it will be a by 2, this side also a by 2, okay. Now the main target is how to use this formula 1 by 2 base into height, isn't it? So base already we have got as a, isn't it? We have got as a. Now we need to find out in here the height, okay. This one is the height, isn't it? So what formula should we use? If we take among those two right angle triangle, here is 90-degree sine, as a result this side forms a right angle triangle, this side is also a right angle triangle, isn't it? So by the help of Pythagoras theorem in that right angle triangle, let's keep just only a right angle triangle, this much only, because the whole triangle is divided into two equal right angle triangles. So let's take this one. So if we use in here Pythagoras theorem, then hypotenuse becomes x, and then perpendicular becomes h, and then base becomes a by 2. So if you use Pythagoras theorem, then what happens? Perpendicular square equals to, we know that hypotenuse square minus base square, isn't it? So in the place of hypotenuse, the value of hypotenuse is given as x, and then after its square, x square. Then after minus b square means the base square, it means a by 2 whole square. And when this square goes that side, it becomes the root under just only. Now in the place of p, it is height, so we can write as h. Now x square minus a square, now 2's square, it will be 4. Now whole root under. Now if you take the LCM of this 1 and 4, it will be 4, and then after 4x square minus a square when we take the LCM. Now whole root under is there, isn't it? Now if we take out the root of the down one, as it is not possible to take the root of upper number numerator, we can take the root of denominator only. So 4x square minus a square divide 2, now whole root under. This is the height of this isosceles triangle. Once again, the whole isosceles triangle, in case of equal sides I have written as x, and then after non-equal side I have kept as a. Here is a, okay, but half part of the isosceles triangle I have erased in order to form the Pythagoras theorem. Now we know that a perpendicular line through the vertex of an isosceles triangle is perpendicular bisector to the base. It means the whole base is divided into 2 equal halves. This side will be half and this side will be half. Okay, so overall the non-equal side a is divided into 2 equal halves as a by 2 and a by 2. Half means a by 2. So if you see in this right angle triangle, opposite to 90 degree x, so hypotenuse means x, and then after perpendicular is formed as h, and then after base formed as b formed as a by 2. So when we use the formula of Pythagoras theorem, p square equals to h square minus b square, our target is to find out the perpendicular or the h. So our target is to find out h. So we use this formula, and by taking by processing it, we got the value of h as root under 4x square minus a square whole divide 2. Okay, now if you keep this one, okay, 1 by 2 in here, okay, 1 by 2 base we had at the time, what was the base in right angle isosceles triangle? The base was as a. We had suppose the base as a, and then after equal side we suppose as x, and the height as h. Okay, now 1 by 2 base means the value of base is a, and then after height we got as root under 4x square minus a square, and then after there is no root in the denominator 2. Okay, now let's multiply all together. What happens? 1 into a, 2 2s are 4. Denominator will multiply with the denominator, and then after numerator will multiply with the numerator. So 1 by 2 into a by 2, it equals to a by 4. Now in the numerator there is what? 4x square minus a square inside the root. So this is the formula of isosceles triangle. In this way, the formula of isosceles triangle is derived from 1 by 2 base into height. So rather than doing root learning, घोकेर भन्दा यसरी बनाएर गर्न पर्ने, जसले गर्छ त्यो विद्यार्थीले चाहिँ म्याथमेटिक्समा राम्रो नम्बरहरू ल्याउँछ, dear student. So keep in mind, this is the way of deriving the formula by using the general area finding out formula of triangle 1 by 2 base into height in case of isosceles triangle. Now let's take another. By using the same 1 by 2 base into height, we can prepare the formulas of other sector as well, other figures as well. So let's take trapezium, area of trapezium. Okay, area of trapezium. How to find out? What like figure is known as trapezium? Of course, the two sides are parallel to each other, and the two opposite sides are parallel to each other, and the other two are not parallel to each other. It is halfly parallel figure, isn't it? And dear student, what thing we have to know is, we suppose the parallel line as parallel line first and parallel line second. To any one you can keep as parallel line first and parallel line second. Now ultimately let's construct a perpendicular line. Dear students, perpendicular line we write as height. as it is the altitude. And what we have to know, dear student, is in between the two parallel lines, okay, for example, these two lines are parallel to each other. When these two lines are parallel to each other, at the time, if we draw perpendicular lines, several, okay, so many perpendicular lines in this way, if we draw, then the length of those perpendicular lines are equal to each other. In between the two parallel lines, how many perpendicular lines are drawn? Those all perpendicular lines are equal to each other. So, by taking the same concept, that means in between the two parallel lines, the perpendicular line, wherever we draw, maybe in here also, you can draw in here also. So, those lines are equal to each other. Whenever necessary, we can use the height, we can use that perpendicular line as a height. Now, let's divide the whole trapezium into two triangles, okay, by joining the diagonal. I am going to join this diagonal, okay. Now, we have, and then after this height, okay, height of this triangle is also this one, because in between the two parallel lines, the heights are equal. I have already told in here. So, the height of this figure also, if we draw in this way, then here will be 90 degree. So, as this triangle is arrived up to this straight line, so we can imagine this triangle's height also as this line, okay. So, it can be as h. So, if you use the triangle's formula, okay, 1/2 base into height, area finding out formula of a general triangle, then in the place of this triangle, okay, for this triangle there are two triangles, one is ABC, another is BCD, okay. Now, if we combine the area of triangle ABC and BCD, we can get the total area of the trapezium. So, area of triangle ABC plus area of triangle, which one? Triangle BCD. If we combine together, it will be the area of whole trapezium, isn't it? Now, let's start deriving the formulas of triangle ABC as well as BCD, and let's combine together all together to have the area of trapezium. DC is a trapezium. So, 1/2 area of triangle ABC, 1/2 in the place of base. What is the line? P2, 1/2 P2, okay. This one is P2, and into what is the value of h? It is as h, exactly as h, isn't it? So, it is the area of triangle ABC. 1/2 base, in the place of base we got as P2. So, if you see the triangle ABC, the base is being as P2, and then after height as h. So, we kept as h. Now, plus 1/2. In case of BCD triangle, just only watch out that BCD triangle, 1/2 base, as here is 90 degree. So, base becomes P1, parallel P1 P2 means parallel line first, parallel line second. You can suppose to anyone, you can keep in here also as P1 and to that one as P2. So, P1 as base, and then after, of course, the height remain the same, as the both figures are in between the two parallel lines. Wherever we draw the height, their heights becomes equals to each other. Now, let's take the common in between these two terms. What is common? Of course, 1/2 is common, isn't it? And then after, not only 1/2, there is common h as well. So, h is drawn in front, okay. H is taken as common. Now, what remain in here? P2, and then after here remain P1, okay. Now, alphabetically if you write, then P1 comes in here, and then after P2 goes that side, and overall the formula is derived as P1 plus P2 1/2 as bracket P1 plus P2. So, in this way, in your book you will see the area finding out formula of trapezium as 1/2 as bracket P1 plus P2. But if you know this formula, then you can derive the formula whenever necessary to you, okay, rather than doing rote learning. So, once again, the whole trapezium, the name of the trapezium is given as ABDC, where AB and CD are parallel to each other. AB I suppose as P2, and after CD I suppose as P1. Why P1 P2? Because they are parallel line. parallel to each other. So parallel first, it means parallel first, and this means parallel second. And I have drawn a diagonal of the trapezium. I just join B and C, okay, a straight line B and C, which is the diagonal of the trapezium. And I just constructed from the vertex C a perpendicular line to the parallel second, okay, which one is known as H. Now similarly, we can construct the perpendicular line to that triangle also. Here is 90 degree, and then after the height both are equal to each other, so we don't need to write H1 and H2. Their value are equal because they lie in between the two parallel lines. Now if we use the formula simply by separating triangle ABC and after triangle BCD, then if we use this formula, then 1/2 P2 into H, this will be the area of triangle ABC. Now 1/2 P1 into H, that means 1/2 base into height. So it will be the area of triangle BCD. Now when we combine together, if we see in here, 1/2 is common in between the two terms, and then after H is also common because the height of the both altitudes are same, so we can keep as A is the value of P1 and P2. The measurement of P1 and P2 are different, so we need to write as P1 and P2. So S is common, 1/2 is common, and what remain here? P2, and what remain in here? P1. So P1 came in here and P2 goes that side. As a result, the overall area of trapezium finding formula we derived. So you can try yourself in this way. Now let's go to area of quadrilateral. How to derive the formula of area of quadrilateral. Area of quadrilateral. It's a general polygon having 4 sides and 4 angles, isn't it? The quadrilateral has different types. One is parallelogram, another is square, another is rectangle, another is kite, and so on. Rhombus, isn't it? Those figures having 4 sides and 4 angles. Now let's draw a quadrilateral. Okay, this is a quadrilateral. Okay, now I am going to join a diagonal, and then after I am going to draw a perpendicular line to the diagonal. Okay, let's keep perpendicular line first. That is not parallel line, dear student. In the trapezium, P1 means parallel line first, but in case of quadrilateral, it means perpendicular line first. Okay, I have supposed as P1. Now similarly, if we draw a perpendicular line to the downward triangle, then let's keep this perpendicular line as perpendicular line second, P2. Now what is the name of this one? Of course, diagonal we write as D, the length from A to C. Okay, let's keep to this one as B, and thereafter to this one as D. Okay, now AC is the diagonal of the quadrilateral ABCD, and let's keep here as O, and after let's keep to this one as M. BM is perpendicular line second, and after DO or OD is perpendicular line first. Now again the whole trapezium is divided into 2 triangles, and if we are able to use the formula of 1/2 base into height in the both triangle, then if we combine the measurement of those 2 triangles area, then it will be the area of quadrilateral, isn't it? So let's try once again. 1/2. Now first of all, let's check the area of triangle ABC, the down one. Okay, just only watch out this triangle ABC, area of triangle ABC, and then after plus area of triangle, what is the name of the upper triangle? ACD. Okay, area of triangle ABC plus area of triangle ACD, altogether if we combine together, it will form the area of whole quadrilateral ABCD. Now let's derive the formula of triangle ABC. Of course, in this triangle base is diagonal, so 1/2 diagonal comes as base, and then after In the place of height, it will be P2, isn't it? It will be P2. And then after, again, plus 1 by 2, let's take the area of triangle ACD. In the place of base, the same diagonal comes as D, and then after, height is mentioned as P1. So let's add all together or take common, and let's finalize the formula of quadrilateral. 1 by 2 is common. In between the both term, there is 1 by 2, so we have taken common, and D is also common, isn't it? D is common in both. Now what remaining here? Here is P2 and here is P1. Already other are common and we have taken in the front. Now 1 by 2 D bracket P1 plus P2, because P1 comes at first in comparison to P2. So this is the area deriving formula of quadrilateral. Directly you will have in book written 1 by 2 D bracket P1 plus P2, where P1 represents perpendicular line first, and where P2 represents perpendicular line second, and D represents the diagonal of the quadrilateral. And when you will have the question, dear friends, the value of perpendicular line will be given to you, and after the value of diagonal will be given to you. At the time, by using this formula, you can find out the area of quadrilateral, whatever the name given in there. Okay, as per this, A, B, C, D is the quadrilateral. So by using this formula, we can find out the area of quadrilateral. Now let's take another. By using the same formula, another formula. Okay, area of let's take rhombus. Okay, how to find out the formula of rhombus? What like figure is known as rhombus, dear friend? A figure or parallelogram having all sides equal to each other but not the angles. All sides are equal, and all opposite to the sides, opposite sides are parallel to each other. This one is known as the rhombus. So can you derive? We need to draw the perpendicular line, of course, and we need to divide the whole rhombus into two. And another thing is, when the diagonals of rhombus comes in this way, there are two diagonals, one is D1, another is D2, isn't it? So D1 and D2. So by using that formula, 1 by 2, if you take this triangle, 1 by 2 base will be, you can suppose to this one as A, this one also becomes A, this one also becomes A, this one also becomes A, okay? And after, to this one you can suppose as height. So can you try yourself, dear friend? Once try as like as the other trapezium quadrilateral that I have done just now. Okay, your turn to derive the formula of rhombus. Altogether, at last you will have the formula 1 by 2 D1 into D2. This is the formula of rhombus to find out the area. You need to get this one by using that formula 1 by 2 base into height. Can you derive? Try at home. Okay, now I'm going to take another, and just I want to give you by providing the hints of parallelogram. Okay, let's take the parallelogram. Opposite sides of parallelogram are parallel and are equal to each other. These two are equal, and then after these two are equal as well as parallel. That figure is known as parallelogram, A, B, C, D. Now let's construct a perpendicular line. This is perpendicular line, so we can write to this one as H, and let's the same perpendicular line, if we draw from here, they are equal to each other because they lie in between the two parallel lines, isn't it? So to this one also you can suppose as H, and let's divide the whole parallelogram into two equal halves because diagonal bisect the parallelogram. And if you convert, okay, to this one, in order to derive the formula of rhombus, if we take that concept, then it will be easier. Area of parallelogram, in short form, parallelogram is written in this form, okay, in this way. So 1 by 2 always it comes, isn't it? 1 by 2, and then after base, you can suppose to this one as base, and then after you can keep, if you take the triangle ABD, then 1 by 2 base into height, okay. This is the half part of the parallelogram. Now again, if it is base, opposite sides of parallelogram are equal, so this one also remain as base B. So if you take that triangle BCD, okay, just now we have taken the triangle ABD, now add another triangle 1/2, base means to this triangle, base means B, and then after CD you can write as B, and then after height as H. Okay. Now 1/2 base into height plus 1/2 base into height, if we combine together it will be 2/2 base into height, isn't it? Altogether 2 cancel, remain base into height. So in this way the formula of parallelogram is prepared. So if you use this concept in case of rhombus, then you can prepare the formula of parallelogram as well. So these are the ways of deriving the formulas just by using the two formulas. One is the product of adjacent side and then after sine angle, okay, and another one is just we have used 1/2 base into height. So in case of equilateral triangle, for example, if question say to find out the area of equilateral triangle, I am going to take some of the example from now, okay, as we have derived almost all the formulas. Now let's focus on what like questions will be given in the examination. Let's take one question. The area of an equilateral triangle is 36 root under 2 centimeter square. Find its length of the side or find its sides. Okay. If we need to find out the sides, so look at here, what type of triangle is this? Equilateral triangle. So keep in mind what like triangle is known as equilateral triangle, or triangle having all angles equal to each other and all sides having equal to each other. So if you derive the formula, just only simply make a figure, all sides we suppose as A, and after all angles are 60 degree. So 1/2 A into sine 60 degree. At the time we did, dear student, that's why you should not be confused. So if you use this one, then what happens? 1/2 A into A square, and what is the value of sine 60 degree? Root under 3/2. So if you combine 2 to the 4 and root under 3 ones are root under 3, now A square. So this is the formula. So when you will have the question given at the time, you need to remember this concept so that you don't need to do root learning of this formula, ताकि यो फर्मुला घोक्नु नपरोस्. क्वेसन देख्ने बित्तिकै हामीलाई यो कन्सेप्ट चाहिँ आउन पर्यो, ठ्याक्कै आउनु बित्तिकै हामीले गर्न सक्छौं. So let's use that formula. Area of equilateral triangle equals to what is given? 36 root under 2 centimeter square. Let's not write the unit, at last we can mention the unit. Now in the place of left hand side, let's write the formula. Root under 3/4 A square equals to 36 root under, I am going to change this one, okay, root under not 2, root under 3, so that it will be easier to cut out, okay, root under 36 root under 3. So now if you cross multiply, what happens? Root under 3A square, ones are root under 3A square. Now what will be? 4 into 36 root under 3. Now A square equals to 4 into 36 root under 3 divided by root under 3, isn't it? Now root 3 cancel, it remain what? What will be the value? 144. 36 4 are 144. This side A square. Now if we take the root of left hand side, in the right hand side it will be root under 144. Now it equals to 12, and the length of anything we write to in terms of power 1, as the unit is centimeter square, so we can write to this one as centimeter only. So the value of the side, find its sides. Question has given us to find out a side, so the side is 12 centimeter. That means if you draw a figure, in this case the equilateral triangle, the all sides are of 12 centimeter if the area of the equilateral triangle is 36 root under 3 centimeter square. So that's all, dear students. Try those formula to derive. You need to be able to derive the formula at first. If you know how to derive those formula, as like how did I do, you can solve those all questions which are present in your book as well as in the examination. Thank you so much for watching. See you again.